Now, direct delta function or impulse. We know impulse force means what? In physics we studied when a heavy amount of force acting on a body for very small time, then that force is known as impulse function. Think it here. How we define the function? See here. This is T, this is del, actually del epsilon. We didn't find del epsilon. This is time interval. We have taken A and this is A plus epsilon. Epsilon is very small quantity. And this much length. We have denoted by 1 by epsilon. So, how we define del epsilon T minus A? This is 0 for T less than A, for T greater than A and less than A plus epsilon. What is the value? 1 by epsilon and 0 when T greater than A plus epsilon. So only for this small interval it is defined, and what is the value? 1 plus epsilon. Now see, when we reduce the interval, so it means what we are doing? We are tending epsilon tends to 0. When we reduce, so epsilon becomes 0. And when epsilon becomes 0 or tends to 0, what is force becomes? 1 by 0 means infinite, because epsilon is here. So that's why it is called impulse function. When we take limit epsilon tends to 0 del epsilon of T minus A, it is known as del T minus A, means impulse function or direct delta function, which is also known as chronicle delta, means value is 1, and for others it's always 0. So now what is the Laplace of del T minus A? Its value is e to the power minus as. Just one formula is there, and that is the Laplace of direct delta is e to the power minus as. Okay, so hope you understand, but just this formula required, because when we go for inverse Laplace of e to the power minus as, what we get? Del T minus A. So that's why it's very important. Laplace inverse of e to the power minus as is what? Del T minus A. So, and Laplace inverse of e to the power minus as by s is ut minus A, means unit step. So both functions are very important. In next lecture I will explain you about periodic function and convolution theorem. Thank you. So please like, share and please subscribe. Okay, thank you.